Because I'm not going to be in the office on Thursday, I'm going to do a quick review for you here. I want you to be observant and pay attention because I'm going to be asking you some questions that are going to be about this video and not always about the content, just to see if you're watching. I'm doing that because I think it is critical. It's been a while since we touched on this stuff, and it is critical that you listen to this review if you want to do well on the exam. Let me back up and start in Module 4. We talked a little bit about the web and the World Wide Web, the internet, networks, and things of that sort. Then we went into web pages. Let me just go through a few things. I've made some notes. And again, you must read it, and you must take notes, and you must pay attention. Anything in that text is fair game on the exam. But I have gone through and just made some notes of some things that I think you may be more likely to forget, may be one way to say it. So pay attention to the idea that the internet and the World Wide Web are not the same thing. The internet is a huge network of network. It's a worldwide public network that connects millions of networks. The web is simply an application that runs on the internet. It's a program of connected web servers. Web pages are stored on web servers. And so the World Wide Web is about things that are stored on web servers, web pages that can be viewed by browsers. And so don't get confused and think the internet and the World Wide Web are the same thing, because they're not. Now, we said the internet is a network, and a network is simply connected computers or other devices. Maybe it will be computers and printers and shared resources. But when these are connected, this forms a network. And of course, then the internet is the granddaddy of all networks. It is this huge global worldwide public network because it is completely open to the public. It is not in any way locked down and protected by passwords and things of this sort. It's available to everyone. So web pages are stored on web servers, and when we click on a link and to get to a website, that site may have many pages, but we're going to arrive at the landing page. The landing page is the page that the visitor sees when they click on that link or that ad or whatever. And so the web browser, of course, is a software program that requests and downloads and displays web pages. We tell our browser what we want to see. It makes that request. It goes, it gets it. It displays it. Now, the internet is public, but most of us don't have a permanent connection to the internet. But we use internet service providers, also referred to as ISPs. These are businesses that have permanent internet connection and provide that temporary connection to individuals and to companies. The IP address is that numeric address of a computer. Any computer that's connected to the internet is going to have an IP address. It's going to have that numeric, 162.192. And so forth. But we also know that the domain name is the text version of that IP address. So because I don't know, and it would not be convenient, nor would it be easy to catalog and distribute all of these IP addresses, we use these domain names. So we may say Amazon.com instead of all of these digits, and this is the text version of that of that URL. I'm sorry. The URL is the Uniform Resource Locator. That is the address of that. I'm sorry, I confused the two, but it is the address for that website. But we use, and they're going to have at the very least, they're going to have a domain name and a top level domain like usi.edu. That may be all we have. That just means USI is the domain, and the top level is that edu. Now, edu means an educational institution. In your book, there's a list of top level. There are many of them now. I can remember when there were just a few. .com for commercial, .net for networks, .org for nonprofits, .gov for government, and so forth. But you can see that in your book. Web pages are written in. We know we used HTML to develop some web pages, which is simply text and tags that kind of define the format of the structure of the page, not how it looks. That would be cascading style sheet or style declarations. But HTML is basically tags. They're simply little codes that tell the browser how to react and how to structure. We know that when we developed a page, we had two main sections. We had a head section and a body section, and we know in the head section, that's only technical information. Nothing in the head section ever gets seen by the person looking at the web page. You only see what's in the head section if you're looking at the code, at the source code. In the head section, we would have comments that may say this was written by Jennifer for this reason. We would have maybe the title, and that's the title that shows up in the browser tab, not talking about the title of your business that's a heading on your page, the title of the actual web site. And you would also put your style your style sheet and your CSS declarations in that head section as well. Now, in the body section, you would have all of the text and the tags, and it would be all of the information that will be viewed and will be visible to anyone that is looking at viewing the web page. So it would be your headings, your paragraphs, all of your text, what you want to say to your customers, the pictures, the logos. Anything that the people visiting your web page will see is in the body section. If you do not have it in the body section, it will never be seen by the viewing public. Now, we also know that if we open a tag, we have to close it. So if we open the body, then at the end of it, we close it. And the difference in those two tags is that slash mark. And of course, I just made it backwards because I'm looking at the screen. But slash body at the closing. The one thing that we close that doesn't slash is a comment. A comment has an exclamation point and two dashes. And then the way you close that is just the two dashes, with the rooftop. But by and large, we're opening and closing those tags. Remember, we have H1, H2, H3, H4. These are heading levels, and they will appear different. If I say this is an H1, it's going to be big on the page. If I say it's an H2, it's going to be smaller in 3 and 4. So an H1 is a basic web page element, but it represents the highest level of a heading that we can have on a page. And of course, the body includes the content that's visible in the main window of any web page. CSS is the language that we use to specify how it should look. HTML is going to be the structure of the page. CSS is going to be how it should look. The background needs to be green. The font needs to be red. It needs to be in bold, and it needs to be centered, and so forth and so on. We have these style rules that we call declarations. They are enclosed in curly braces, and they have a property and a value. The property is what you're wanting to do to the information or the text or the row or the header or whatever. The property, colon, and then the value. I want to text align, colon, center. Text align, colon, left. Would cause everything to be to the left. And so those are called declarations, the property and its value. Now, at the end of that value, we have to put a semicolon. We can end it right there, or we can chain together several of them. So a semicolon would be used to separate these declarations, this property and its value, semicolon, property, colon, value, semicolon. In front of the curly braces, we would put our selectors. These are the P or the H1, or we're telling what parts of the page we want to be impacted by this declaration. If I'm saying text align center, what do you want centered? H1? Header 5s? Level 5 headings? Paragraphs? What? So those are selectors that we put in front. Remember, any of these style rules, this style section would go up in the head, never in the body. Never in the body. Remember that we had a storyboard and wireframes. The wireframes were the little showing you, well, we're going to have this picture here and this text here, and you're kind of mapping out and laying out on the page. So a wireframe is about how a page is going to be arranged, and a storyboard is about how you're going to go through the pages. You know, this page connects to this one, and, you know, like what's page 1, 2, 3, and 4, and so forth. So the storyboard would be about multiple pages. A web page can appear slightly different on multiple browsers. Remember that. Every browser, I mean, we're using the same protocol and they're all going to be similar, but the rules are such that it allows a little bit of fuzziness, so it can appear a little bit different on multiples. I've already told you the embedded style sheet would always be in the head part. And the comments would begin with a exclamation, space, space, and we would separate our style rules with a semicolon. I think that touches most of the stuff that we did in Module 4. Now moving into Module 5, security. We talked about some things like security is both a process and a goal, and it's a goal that we will never reach. We will never be completely secure. We may be secure for a second and then move on, you know, something's happened. We just can't stop, is my point. We can't just say, I've reached, and it's never over. Your book talks about all of the reasons why it's very difficult to defend an attack today. And I'm not going to go into every one of them. I'm just going to tell you should know them. But they're things like we're universally connected. The speed with which vulnerabilities can be detected, and so the speed with which attacks can occur, the sophistication of the attacks today. And so there's a list of those. Make sure you get in your book and you pay attention to each of those. We know your book talks about, and this is, I think, toward the end, but it talks about 4 key elements to create a comprehensive security strategy. And these 4 elements are going to be blocking, updating, blocking attacks, updating defenses, minimizing losses, and staying alert. So make sure you've paid attention to those. Pay attention to those terms in there, like a vulnerability is a flaw or a weakness, the threat agent, the threat vector. Pay attention to those terms, please. Also pay attention to the CIA. the confidentiality, integrity, and availability. And there are several A words, so make sure you know which A goes with CIA. And then also authentication, which is making sure that only authorized, authentication is is making sure that you are who you say you are. Therefore, its goal is to make sure only authorized people get in. And so you have authentication, that's determining you are who you say you are. And then authorization then is allowing or granting the permission. And then, of course, accountability is the tracking. It's that paper trail. It's that ability to say you are the one that made this change because I can see it, in your paper trail. We've talked about it being a process and a goal. We talked, also remember that the greater the security, usually the security goes up, convenience goes down, that inverse relationship. The more we secure, the less convenient it is, and we have to try to find that happy medium somewhere there. We've got to continue, to and I'm trying to think. I'm sorry, I'm thinking of a different module. That's my bad. Also, remember when we look at these actors that do infiltrate or interrupt our systems, we have script kiddies. These are people, I think your book said something like 40% of the attacks require very little skills, but script kiddies are called kiddies because they're very inexperienced in terms of their sophistication and their ability to manipulate the hardware and the software. They use these tools, these scripts that are, they just don't have to have a lot of skill. So script kiddie are hackers with very little knowledge. And then we could talk about our you've got hacktivists, which have the activism. You've got your cyber terrorists that, of course, are going to be political and ideological. Your brokers that are going to attempt to sell what they know about your vulnerability or sell the information. The layers, the three layers, the people, the procedures and policies, the people and the products. Here's the CIA. You're trying to, keep the information confidential, which means only allow appropriate people to see it. You're trying to keep the data, make sure it has integrity, which means, again, only the appropriate people can touch it or can change it in any way. And then, of course, you want it to be as available as it needs to be. So here is our goal, and we know that we use products, we use people, and we use policy and procedures. And all of these work together. The people use the products, but the policies, dictate what the people can and cannot do and how they would and would not use and so it all works together. So make sure you've paid attention to this as well. Risk. When we approach risk, remember your book talks about various approaches to risk. We all can, we're going to run into risk in our daily lives all the time, and sometimes we can just say, I'm going to accept that risk. I mean, yeah, this is very likely to happen, or this may happen, but I'm just going to accept that risk. I either think it's not very likely to happen, so I'm not going to worry about it, or if it does happen, it's not going to cost so much so I just accept it. I'm not going to do anything about it. That is probably not practical from an information security viewpoint, not most of the time anyway. There may be some information that, we don't care if people find, but most of the information we're talking about, we're not going to just accept the risk. We may decide to avoid the risk, which means, well, I won't get hacked if I don't have a network. That's one way to avoid the risk. That's usually not practical. Avoiding risk is not always practical in a business sense, because typically the risks are things that we must be involved in, and we can't just say I'm gonna, I'm gonna make sure I'm not exposed to that risk. That's just usually not an option. But your book talks about deterring the risk, doing things to try to make it less likely to happen, or to minimize, to try to minimize what would be the loss or the damage. And then finally, we can transfer the risk. Insurance is a perfect example of risk transference. Usually we use a combination of these, but make sure you've read and understand those things in your text as well. Some of the legal, some of the laws that have been passed, there are a lot of laws that have been passed. Some of them are more common and more familiar to you than others, but a couple of them that I think you surely need to remember are Sarbanes-Oxley, sometimes called Sarbox, sometimes called SOX. But this is about making sure that corporate officers are responsible and a kind of a paper trail, and making auditing and making sure that they can't falsify records. It carries like a $5 million and a 20-year. It's powerful legislation. HIPAA, the Health and Insurance and Information Portability Act. You have to be a portability. You have to be very careful with health information, and the bottom line is nobody should ever see anybody's health information except except the people that really are authorized to do so. And so again, you can lose medical license. I mean, there's different levels of punishment, but it's very, very important that the information be both private but at the same time be portable. So that's what HIPAA's about. Remember those terms in your book. I can't remember if I've said this yet, but threat agent, threat vector, vulnerability, which is a weakness, and those terms, so that if in your test, if there's an example and says which of this is the threat agent or which is the threat, or that you'll understand what it is. I think that's all for that chapter. So now let's pop into module 6, which is a big one. We talked about data first. We talked about databases. We talked about relational databases. Access, Microsoft Access is a relational database. I drew those on the I used drew the flat files, the tables, and showed you how to use key identifiers and putting them together and tying the tables together in a relational format. So relational databases are really widely used today, and Microsoft Access is an example of such a database. So we talked about databases, and a database is a collection of related data, maybe in a central location, maybe in multiple locations. We also talked about how data used to be in flat files. We talked about the database management systems now that we use. It's software that we use to create, to store, to maintain, and to access our database files. And before database management systems, DBMS systems, we had just the flat files, so we had a lot of data redundancy. We had program data dependence. We had a lot of errors and a lack of integrity and a lack of the ability to share. And so your book talks about all these advantages that come from the DBMS era, or from that technology. And today with big data, we're having to develop even newer and different types of databases that can deal with unstructured data as well as the structured data, and that can also deal with the volume of the data that we have today. I'm thinking of then we talked about data warehousing. The key there is that it's subject oriented, time variant, and its specific purpose is analytics and decision making, as opposed to transactional data that is based, that is transactionally focused and just not arranged well for decision making. And we talked about how we take both our transactional data, any internal data, maybe even external data, whatever data we need in this data warehouse, and it depends on the type of decisions we're going to be making. But we talked about the process of getting the data from other sources and into the data warehouse, and we talked about ETL, extraction, transformation, and loading. So make sure you remember that. We talked about a data mart being a small version of a data warehouse. We talked about data mining that helps us discover patterns and relationships, slicing and dicing, if you will. A database. Then I guess we went into talking about, we kind of moved into the discussion of decision making in the organization, where we talked about the decision making process, the 3 phases of the decision making process: intelligence, design, and choice. And the more we understand about each of those 3 phases, the more structured that decision or that problem is. And so the more structured it is, the more likely there's going to be a known solution, if you will, for that particular data or for that particular decision. Procedures exist already because that's been done and been understood and been known. We talked about the various levels in an organization and how the data differs among those organizations. But basically, we said that, and then I guess we went into talking about, and I guess back when more connected to the data warehouse, we talked about big data, and we talked about the 3 V's of big data. Big data is voluminous. It does have great volume. It is big. But it also has great variety. It is not just structured data. It's all types of data, from social media, text, pictures, gestures, whatever. It's very high in variety. And then velocity, the time with which we have to process that data and respond, is just ever decreasing. So we talk about the 3 V's of big data: volume, variety, and velocity. And of course, I said earlier, we have newer and different, like Hadoop and some of those different types of technologies and databases that will deal with this unstructured data, and that will deal with this ridiculous size, and that will deal with this speed and with this volume and with this variety. We talked about then some systems, and I guess let me back up and say we defined business intelligence and as being more describing our data, and then we talked about business analytics, and business analytics I think we defined it as using statistical methods for I'm sorry, I'm very thirsty. We talked about business analytics, and we talked about using statistical analyses. We talked about doing more proactive, more predictive, and prescriptive, where business intelligence was more descriptive and more backward looking. And and then I guess we looked at, business intelligence, we said, uses data and statistical methods to gain insight into data. But we talked more about how it's forward-looking. And then we talked about, in general, your book talks about this very broad term that's used for systems, kind of a collective term for systems that help management make decisions and so forth. And that term was MSS, stood for Management Support Systems. But among those systems, we talked about a few specific types. We talked about decision support systems. And decision support systems, we talked about having a database component, a model, a database, a model base, a database, an interface, and then that database engine. And that there's a model in your book that talks about this. These are the components of the database, or the DSS. And a DSS is identified with what-if analyses and goal-seeking analyses and sensitivity analyses. These are the things some keywords that we associate with decision support systems. And then we talked about Executive Information Systems, EIS, which is like a type of DSS for executives. Executives need it to be very user-friendly, so they're typically going to be graphic, highly graphic. They're often going to use they're pretty much always going to have dashboards, and dashboards kind of integrate and display the information and present the information in kind of a unified, understandable, like charts and graphs. Kind of like maybe, if you're looking at your dashboard on your car and you're seeing some gauges with key indicators and things. You're not seeing scientific decimal numbers on the compression of you're seeing, the engine's okay or it's not. It's cold, it's hot. It's very user friendly. So it integrates all of this information and displays it in a kind of a unified and an understandable format. So Executive Information Systems will typically have a component. See that book? Might ask you a question about it. So executive systems, that a keyword that you're going to find with EIS is drill down, the ability to drill down deeper. So they're oftentimes going to be very data based because they're not as predictable and on the executive level. So they need a lot of data, but that data needs to be presented in a fashion. So dashboards are pretty common, and then of course the ability to drill down. The success of an EIS is obviously you've got to have top management support. You've got to be able to, make sure that you understand your objectives, define your objectives very well. And then I guess we can talk about group support systems. Group support systems are systems that are designed for like board meetings and task forces and things like that. This would be a classic example for group support systems. Systems that will support groups. Now, your book talks about group support systems. It also talks about electronic meeting systems. But group support systems also, they help groups do better decision making. It's not just about collaboration and communication, but it's about promoting of the decision making environment. And so they help us to collaborate. They help us to by not traveling, we spend less money, less cost, less time. Also, you have issues like anonymity. Sometimes people, because of their personality, will not be involved if their comments are being tied to them. Sometimes it's because maybe they disagree with their superiors. But at any rate, the ability for anonymity can oftentimes improve the decision-making process. It can make you less likely to be involved in groupthink. So there are a lot of advantages, but of course you lose the human touch. So that's that disadvantage. And I think that covers, oh no, the geographic information system that uses points and lines and areas, of course, and displays information in a graphic and geographically by using points and areas and lines, and we know there are many you can read in your book the various applications for those. I think that's all of my keynotes there. Now I just want to tell you just a thing or two about in terms of review on the enterprise. We've not lectured that yet. I'll be lecturing it in the morning. So it's all I'm doing here is just kind of a review, not doing the lecture. So it's going to sound a little broken right now, but by the time you view this, it'll make some sense. Basically, an enterprise system is about information sharing across all of the functions, across the entire enterprise. So think about, and then ERP is a particular enterprise system, enterprise resource planning, that integrates various processes and helps to manage the vital operations of the company. The bottom line is that enterprise resource planning it's a set of integrated modules or components, if you will, but it's a single database. So if you will, think in terms of MyUSI and how we have one database, your name's in there once, and the library uses it, and the bursar uses it, and the registrar uses it, and I use it, and the left hand can see what the right hand's doing, if you will. Think about the time, and we'll do this more in lecture, but as opposed to standalone systems and legacy systems, but as opposed to that, so a system that encompasses all of these processes and integrates all of this into one big system. Let me see. ERP, I'm just trying to think in terms of review, what kinds of things key things that are going to be maybe difficult for you. Actually, we're going to be lecturing this right before the exam, so that's why I'm not thinking the review here is so keen, but not such a big deal. But basically, when we talk about ERP, we're talking about, we historically have talked about internal functions like the production and the procurement and the manufacturing and the sales, and the accounting and the HR, all of that internal stuff. But it is real common now, and getting more and more common, that we have some external, some components that connect us with external entities as well. And two of these that we're seeing become a part of ERP are supply chain management and customer resource management. Supply chain management is managing all of the information and the materials up and down the supply chain, and this means like all the way from the from the supplier to the wholesaler to the to the supplier, to the production or the manufacturer, then to the wholesaler, then to the retailer, and then to this whole chain, And so everybody can see all the information up and down the chain, so that, I know exactly when the tree's being cut that's going to be used to make the leg for that couch that I'm going to sell you. Now that's kind of a little bit of a facetious example, but this is what we mean by supply chain management, and we're talking about things like forecasting and distribution and logistics and anything that would have to do with any of those processes all up and down that supply chain. And so then we can we can, this is like up the chain, up the supply chain, if you will, and then down chain, if you will, upstream being the supply end and downstream being the customer end. But we also talk about customer relationship management, which involves anything that has to do with the customer, whether it's the actual transaction or if it's the things leading up to even contacting the customer, or if it's returns, if it's helping a help desk, if it's, absolutely any aspect. Because building a relationship with your customer means that first and foremost, you got to know who your customer is and what they want. And that is data, that is information. And you've got to constantly have your finger on who and what, so that you can always be found giving them the product, the service, and the amenities that they want, when they want, as they want them, and so forth. And so your book talks about several areas, several applications that would be considered a part of that. So CRM is about understanding and anticipating the needs of both your current and your potential customers. And, like I say, sales, marketing, contacts, just all different areas. Any aspect of customer interaction, period. And then I think the last part of your chapter talks about the challenges. I think one thing I didn't say, there are 3 tiers because historically ERP started out being only implemented in the very largest companies, because it's such a tremendous, and in lecture I'll make you understand what a tremendous undertaking it is. How much time, how much money, how much organizational change. It is a horrific undertaking to implement ERP, and it cannot ever be thought of as a technology project. It is clearly a business it's a horrendous undertaking. So the success rate is very, very high, and certainly has the potential to be very, very high. And so we'll talk about that in the lecture, and about how historically, because of all of this money and risk, you only had the top tier people. But now there are actually 3 tiers. We have different vendors. Some of the vendors participate in multiple tiers, but there are 3 tiers of ERP: tier 1, 2, and 3. Tier 1 is the big boys, the very largest firms. Tier 2 for the medium, and tier 3 for the smaller firms. There was a time when the smaller firms couldn't participate in ERP because they couldn't afford they just didn't have the resources, not the time, not the people, not the money to implement. So there are a lot of challenges with ERP implementation. Disruption, organizational disruption is huge. The cost is great, and you've got to manage the change, because you are changing the way you do everything, because this system is going to standardize. It's going to tell you this is the way you will do this process. So, it doesn't respect the fact that you used to do it another way. Well, you're going to do it this way now. Now, there are options sometimes to make adjustments to the software. So that's a big challenge, understanding whether to change my process or to change the software, if you can. Many times you don't have that option. And then, but just making that decision, and then actually implementing the decision, making the changes in the organization, or making the changes there. All of these are very difficult. Okay, going to be asking you some questions. Hope you've watched it and observed.